Cool? So that's probably the hardest part. So we're gonna practice it a little bit, and then throughout your assignment, you'll have some that you have to practice also. Sometimes on the AP test, they already give you the graph, and if they do that, that's awesome. Okay? But we're gonna go through the whole thing. But basically what we're trying to do is, let's say they give you some function, and they give you another function, we're trying to find that bounded space between, find that area between the two curves. There was one like that on the mock exam, but they were asking for volume. So that was like a whole nother thing. We'll look at that next week. Pretty cool? Alright, so we're gonna kind of explore and go through the thing and then hopefully discover the general formula for doing this, okay? So the first thing they ask you to do here is to graph this function f and then evaluate it and find that integral. Find that bounded space, okay? So let's try to graph it. Okay, we know that this is the graph of a what? A parabola. So is it gonna have a vertex? Is it gonna have a maximum or a minimum? This one's gonna have a max because it's negative, so it means it's opening what?
Downward.
Downward, right? How would I find that maximum without having to do what I did in Algebra 2 and in Pre-Calc? I could use the derivative, right, to find that maximum? Because that would be where the derivative was equal to what? To 0, okay? So let's find that vertex using the derivative. Get the derivative of this guy. What's it going to be? Negative x minus 2. And then we want to set that derivative equal to what? To 0 to see where I have a horizontal tangent line, which should be where I have a max. So what do I end up with? X is equal to negative 2? Yeah, because we add 2 and divide by negative 1. Alright, so we know where we're going to have that max, but we don't know specifically what y value. How would I find the y value? Very good. So plug into. So we're going to get y is equal to negative 1/2 times negative 2 squared minus 2 times negative 2 plus 4. So that's 4 divided by 2. That's negative 2, right? Plus 4. That's 2 plus 4. 6. So we know y is what? 6. So we know the vertex, we know that the maximum has to be at negative 2 and 6. Are we good? Alright, we don't have a calculator, we need to come up with a general sketch of this graph to be able to do it. Alright, what would be another easy point to find? The x-axis? That would be kind of hard to do because we would have to find the zeros, right? And this is not factorable, so.
Just do y-axis.
Do the y-intercept, right? The y-intercept, if you remember, is the c value. Or we could plug in 0, right? And we get 4. And remember that parabolas are symmetric, right? So what's on one side of the vertex point should also be on the other side the same distance from it, right? How about another one? Just one more. What would be another number to plug in? Another easy one. So we can get another 2 points. 2? Yeah? Alright, let's plug in 2. See what happens. So 2 squared? 4. Divided by negative 2? Negative 2. And then negative 2 times 2, that's negative 4, right? Plus 4, that's 0. So at 2, it should be at what? At negative 2? Okay, cool. So then that means that over here, this is how many? 1, 2, 3, 4 away? So 1, 2, 3, 4 away. Cool? You guys picked a good one. So we got our nice little parabola there. Alright, now they're asking us to find the integral from negative 5 to 0. So that's like me finding the bounded space from right here to right here, right? And using your color, I want you to color that in. You should have a color on your desk. Or you should have gotten one when you came. Okay, or you can share with the people around. Let's actually calculate that area from -5 to 0 of -1/2 x squared minus 2x plus 4 dx with respect to x. What's the antiderivative of this?
-3 over 2 x to the 30.
Careful. We're adding 1, we get 3, and we're dividing by 3. -1 over 6 x cubed minus x squared plus 4x. Evaluated from -5 to 0. So what do we get when we plug in 0? 0, right? Minus, let's plug in -5. -1 over 6 times -5 cubed minus -5 squared plus 4 times -5. See if we can do this by hand. So 4 times -5, that's -20, that's positive 25, it becomes -25?
Yeah.
Yeah? So -25, this is -125, right? That
125 over
becomes
6.
positive 125 over 6. You wanna divide by 6? I mean, times 6? So if I have 6 quarters, how much do I have?
That would give you
150? So 125 take away 150? -25 over 6, but there's another negative out here, so it actually becomes positive 25 over 6. Okay? Type that in your calculator and tell me what that is. That's a decimal. Did we do that right?
Yeah, what I put at 20.
Yeah, we got the -20.
Oh, we didn't add the -20, just kidding. So that one would also be times 6, so times 6, so that would be,
120.
what? 140?
120.
120? So it was -25 minus 120, so that makes it negative 145? Yeah, there we go. So it becomes positive 145 over 6. Are we okay? Sorry, I messed you up there. What do we end up with here? 24.167, correct. Easy? Alright, now we're gonna draw another graph, and we're gonna find the bounded space of that graph and the x-axis. So they want you to graph this line, okay? So 1/2 x plus 4, how do I graph that? Start at the y-intercept, which is 4, and then 1 up, 2 to the right, or 1 down and 2 to the left. Right? And connect the dots. And then I want you to draw or color in the bounded space for that line. That's gonna be where? From -5 to 0, that should be this space right here, right? Forms a shape, right? With this one, it does form a shape that we can find the area of using geometry, but we're gonna actually use the integral to figure it out. Cool? So let's do that one. That one's gonna be the integral from -5 to 0 of 1/2 x plus 4 dx. What would its antiderivative be? We add 1, we get 2, and we divide by 2. 1/4 x squared plus 4x evaluated from -5 to 0. Okay? Plug in 0, you get 0, minus, plug in -5. 1/4 times -5 squared plus 4 times -5. So that gives us what, 25 over 4? minus 20 over 1, so times 4. So that's what, 80? 25 take away 80? 55? Negative 55 over 4? But times the negative, so it becomes positive 55 over 4? And type that in your calculator to see what that is as it is. 13.75? Awesome. Alright, so let's say I gave you the graph that had these two curves already drawn on it, and I asked you to find the area that was bounded by the two curves, so in this case, this little orange space only. Okay, how do you think I would find that bounded space? Subtract the two that I just found, right? Okay, cool, so let's do that. That's what this is asking you to do. So in order to do that, right, to get the area between the two curves, you said to subtract the two, right? So you're saying it should be 24.167 minus 13.75? Or should it be the other way around?
Wait, wouldn't it give you, wouldn't that just give you like the top half?
Right, that's the space bounded between the two
Yeah,
curves.
it's like this.
Yeah? It's like that? Okay, cool. And what do we get? 10 point, type it in. 417? Beautiful. Good? So do we have a general idea of what we're supposed to do to find the bounded space or the area bounded between two curves? So it would be the integral of which function? In this case, the top one is what? F of x minus
G of it.
g of x from wherever to wherever they wanted, right?
Yeah.
Okay? Now, we do have to be careful which one we subtract from which one, right? So it would have to be the what? The top one minus the bottom one is gonna give us that space. So it's like we got all the area, then we took away the area under this one, and it's gonna leave us just that area there that's between the two curves. Do you understand? Okay? That's the general formula. Good?
Yeah.
So turn it over, and let's see if that's what actually happens. Okay? So if I do this integral, which is what you told me to do right now, let's see if we get the same answer that we got, 10.417. You ready? So what was the top function? What was f of x? Minus 2x. Put it in parentheses. Minus, put it in parentheses, this is where kids mess up. They don't put the second function in parentheses, so they forget to distribute the negative. And then that makes them get it all wrong. Okay? So minus g of x, which is this guy, 1/2 x plus 4. We good? What I'm going to do is I'm going to try to simplify this because I see that I have some like terms. That becomes minus 4, right? So what cancels out here? The 4's, and we can put these two guys together. So really this is the integral from -5 to 0 of -1/2 x squared. What's -2 minus half? -5 over 2x. So I'm gonna actually subtract them if I can first, and then integrate it, so that way I don't have to integrate each one separately like I did earlier, right? I don't wanna have to do that for every single part. Okay, I wanna figure out the formula that's gonna be in there and simplify it as much as I can, then integrate. We good? Alright, so let's do it, let's see if we get the same answer, we should, okay? So what would we get when we integrate this guy? -1/6x cubed minus 5x squared over 4, evaluated from -5 to 0. When I put 0 in, we get 0. Minus, put in the negative 5. Negative 1 over 6 times negative 5 cubed minus 5 over 4 times negative 5 squared. That gives me what? Positive 125 over 6 minus
125.
125 over 4. Yeah? With a negative over here. And I'll let you type that in your calculator. See if we get the 10 points. So I'll allow you to use the calculator on the assignment for the evaluation purpose at the very end, but I do want to see the work. I do want to see you plug it in. Because remember, you add 1 and divide by the new power. So it was divided by 2, then divided by another 2, that makes it divided by 4. Did we get 10.417? All right. Awesome. Okay, so what do you notice about this value? Identical to the previous one, right? So if I do the integral from negative 5 to 0 of f of x minus the integral of negative